we are told that a sample of a compound containing only carbon and hydrogen atoms is completely combusted, producing 5.65 grams of carbon dioxide and 3.47 grams of H2O, or water. What is the empirical formula of the compound? So pause this video and see if you can work through that. All right, now let's just try to make sure we understand what's going on. They say that I have some mystery compound. It only contains carbon and hydrogen. So it's going to have some number of carbon, I'll call that X. Some number of hydrogens, I'll call that Y. We're going to put it in the presence of molecular oxygen, and it's going to combust. And after it's combusted, I'm going to end up with some carbon dioxide and some water. And what I just drew here, this is a chemical reaction that I'm describing. I haven't balanced it. I could try to, even with the X's and Y's, but that's not the point of this video. The point of this video is they tell us how many grams of the carbon dioxide we have and how many grams of the water we have. They tell us that right over there. And so what we need to do is say, all right, from that, we can figure out how many moles of carbon dioxide we have, how many moles of water we have, and from that we can figure out how many moles of carbon did we start with and how many moles of hydrogen did we start with. And if we look at those ratios, then we can come up with the empirical formula of the compound. So just to start, because I'm going to be thinking about moles and molar masses and the mass of a mole of a molecule or an atom, let's just get the average atomic mass for carbon, hydrogen, and oxygen for us to work with. So I'll get out our handy periodic table. We can see hydrogen has an average atomic mass of 1.008. Let me write that down. So we have hydrogen is at 1.008, and then we have carbon, and carbon is at 12.01. So carbon is at 12.01. And we could also think about them in terms of molar masses. We could say this is gram per mole, grams per mole. And then last but not least, we have oxygen. And then oxygen is at 16.00 grams per mole. This is the average atomic mass, but then we can think of that as molar mass, that number as molar mass. So oxygen is at 16.00 grams per mole. And so now we can try to figure out how many moles of C in the product do we have. So we can see that all of the carbon in the product is in the carbon dioxide that's in the product. And so we have 5.65 grams of CO2. We can think about how many moles of CO2 that is. So times 1 mole of CO2 for every how many grams of CO2? Well, we just have to think about, actually, let me just put it right over here. CO2, you're going to have, let's see, you have 1 carbon and 2 oxygens. So it is going to be 12.01 plus 2 times 16, 2 times 16, 00 grams per mole. And so let's see, this would get us to, this is 32 plus 12.01, so that is 44.01. And that's grams per mole, but now we're thinking about moles per gram, so it's going to be 1 over 44.01. And so if we did just this, the grams of CO2 would cancel with the grams of CO2, and this would give us moles of CO2. But I care about moles of carbon in the product. So how many moles of carbon are there for every mole of CO2? Well, we know that we have 1 mole of carbon for every 1 mole of CO2. Every carbon dioxide molecule has 1 carbon in it. And so what is this going to get us? So we have 5.65 divided by 44.01, and then times 1, so I don't have to do anything there. that is equal to, I'll round it to 3 digits here, so 0.128. So this is 0.128, and my units here are, let's see, the grams of carbon dioxide cancel with the grams of carbon dioxide, the moles of carbon dioxide cancel with the moles of carbon dioxide. So I am exactly where I want to be. This is how many moles of carbon that I have. And you can do the dimensional analysis, but it also makes intuitive sense, hopefully. If this is how many grams of carbon dioxide we have, and a mole of carbon dioxide is going to have a mass of 44.01 grams, well then 5.65 over this is going to tell us what fraction of a mole we have of carbon dioxide. And then whatever that number of moles we have of carbon dioxide is going to be the same as the moles of carbon, because we have 1 atom of carbon for every carbon dioxide molecule. So that all makes sense. And now let's do the same for hydrogen. So let's think about moles of hydrogen in the product. And it's going to be the same exercise. And if you're so inspired, and if you didn't calculate in the beginning, I encourage you to try to do this part on your own. All right. So all of the hydrogen is in the water. So, and we know that we have in our product 3.47 grams of water, 3.47 grams of H2O. And now let's think about how many moles of H2O that is. So that's going to be, let's see, every 1 mole of H2O is going to have a mass of how many grams of H2O? And we could do that up here. H2O, it's going to be, we have 2 hydrogens, so it's going to be 2 times 1.008 plus the mass, the average atomic mass of the oxygen. It's going to be plus 16. But we can also view that as what would be the mass in grams if you had a mole of it. And so this is going to be in grams per mole. And so this is going to be, let's see, 2 times 1.008. This part over here is 2.016. And then you add 16 to it. It's going to be 18.016. 18.016. And then if I just calculated this, this would give me how many moles of water I have in my product. But I care about moles of hydrogen. And so how many moles of hydrogen do I ever have for every mole of water? So for how many moles of hydrogen for every mole of water? Well, I'm going to have 2 moles of hydrogen for every mole of water, because in each water molecule, I have 2 hydrogens. And so that's going to cancel out with that, and we're just going to be left with moles of hydrogen. And so this is going to be equal to, I'll take my 3.47 grams of water, divide it by how many grams a mole of water, what its mass would be. So divided by 18.016. This is how many moles of water I have. And now for every molecule of water, I have 2 hydrogens. So then I will multiply by 2 times 2 is equal to I'll just round 3 digits right over here, 0.385. 0.385 moles of hydrogen. So now we know the number of hydrogen atoms, we know the number of carbon atoms, and to figure out the empirical formula of the compound, we can think about the ratio between the two. So I'm going to find the ratio of hydrogens to carbons. And that is going to be equal to, I have 0.385 moles of hydrogen over 0.128 moles of carbon. 0.128 moles of carbon. And what is this equal to? And it looks like it's going to be roughly 3, but let me verify that. In my head, that seems, so I already have the hydrogen there. And so if I divide it by 0.128, I get, pretty close to 3. Now, actually, I think pretty close to 3. So there you go. This is approximately 3. And so I can, with pretty good confidence, this was very close to 3. I can say for every carbon, I have 3 hydrogens in my original compound, in this thing right over here. So the empirical formula of our original compound, for every 1 carbon, I have 3 hydrogens. So CH3. and we are done.